Welcome to XL Catlin Arctic Live. We're here at the UK Arctic Research Station in Ny-Ålesund on the island of Svalbard. We have been here for nearly 2 weeks, about 10 days nearly now, and we've been studying the impact of human activity on the oceans up here in the Arctic. So we've had both research on ocean acidification and today's focus, which is on microplastics. And the next 3 broadcast sessions, which you can access via the Digital Explorer YouTube channel, are all about microplastics. We have a live investigation now. We'll also be taking questions from schools, both those that have been pre-submitted and those coming up on the live chat. After this, in 2 hours' time, we have an interview with Nick Scott, who is a member of the plastics research team, and he's normally based at the University of Exeter in the UK. And a final session later on this evening, probably not evening for those of you joining from North America, but we'll have an open Q&A and Ask Me Anything session to tie up to that today on Arctic Live. But just to start off with, I have in front of me our very own Arctic Ocean, and we're going to be looking at sampling for plastics. Now, one of the tricky things is that we don't really know exactly where plastic particles are in the ocean. So, are they on the surface waters? Are they in the water column? Are they in fact in the sediment at the bottom of the sea? Or perhaps they're inside some of the organisms that live in the ocean, both the tiny plankton up to the huge whales. One place they might be is in the sea ice, and there's some great research just published looking at exactly that. And the difficulty is that there are vast quantities of sea ice in the Arctic, and we're looking at this working scientifically question about sampling. How do I sample the sea ice in the Arctic to try and work out how many plastic particles are in it? Obviously, we're not going to be sampling the whole thing. We're not going to be melting down all the sea ice in the Arctic, or even trawling out here for plastics, which we've been doing over the past week. To trawl the entire fjord would take a huge amount of time. So what we're doing is we're looking at, can we take some samples which will give us a representative picture of the amount of plastics, in this case in the sea ice. All I've got here is a tray with seawater in the bottom, some microplastics. I'm using pink peppercorns. Lentils also work, something organic, so we're not putting anything man-made sort of plastics down the sink at the end. And I've also tried to make this a little bit more realistic by adding a layer of snow from just outside on top. I've got an apple corer. This is going to act as my ice corer, and I've got to try and work out how much microplastics is in the sea ice. And it's great to have schools in the USA, Canada, UK and Italy joining us live for this. We've got Northwest Village School in Plainville, and it's fantastic to have you here. And just checking the live chat just to see who else we might have. Getting that up now. And we have, great. Haven't got any name schools up, probably the names will come very shortly. So it's a bit of a difficult question, this. And so I'm going to have to come up with an idea about how many I'm going to take. Being in the Arctic is also resource intensive. We've got to get up here, we've got to, when we flew up, we've got to stay at the UK Arctic Research Station, there've got to be facilities up here. And so we can't just spend our whole year trawling around or researching. So we've got to be selective about where we might sample for the plastics. So great to have. We've got Livingston High School in New Jersey, Sharon Elementary in Georgia. Welcome one and all. And so I'm going to say, right, we've got time for 4 ice core samples from here to try and judge in the whole area how much microplastics there are. So I'm just going to start off a couple of holes here from earlier. This is the same tray we used earlier on for some of the plastic sampling when we did it earlier this morning. So I'm going to take one sample and do follow along. Good twisting motion. Down through the ice. Sea ice, easier to sample than glacial ice, and we'll have a look at the difference between sea ice and glacial ice tomorrow. But if I can just turn my hand round, maybe you can see it more easily on the camera. So here we see this is very, very cold and not very comfortable. Of course, please use some filter paper. Put your ice core samples on filter paper if you're doing this in the classroom with us. You can also, rather than using hand warmth, put your ice core samples into a test tube or boiling tube and warm those using whatever equipment you have. That might be something simple as a hairdryer or using a Bunsen burner. So here we go, 1, 2, 3, 4, 5, 6, 7, 8, 10, and a tiny one there makes us 14 pieces of microplastic in this sample. Now, can I say, based on a single sample, that for everything I do, there will always be 14 in every ice core, or do I need to take some more and look at an average? Hi from a 5th grade science class in Newfoundland, Pennsylvania. Great to have you on board. How much plastic do I think there will be? Well, let's do one more sample. Let's do one on the corner over here. This is much, much easier than doing it for real. It feels very, very tiring. There we go. And apple cores, I've got to do a little bit of scooping motion as well, just to make sure. Bring up all the ice from down here. I better get the sort of, my previous sample, I'm not being a very good scientist here, my previous sample is still on my wet hands. So really try and rub that off, just so I don't get any contamination. We don't want that. There's a lot of rinsing that's happening on board. So we put up some photographs on Facebook, and there's a lot of rinsing of the nets to make sure you don't get that contamination that nearly happened there. Okay, so I've got this in my hands now. I put my core down. Ooh, melts through that. I think I'm still getting contaminated. Ellie's behind the camera, doing a sterling job. Basically, it's because of Ellie that thousands of kids around the world have been able to join us here. She's been making sure that works. So we can see that there's my second plastic sample. So I had 14 or 15?
14.
Well, that's great. No plastics in this bit of ice. That's good news all round. And little bits of, who knew that little bits of pink peppercorns could be so sticky. And then for Hi from Cloudy, Portugal. Brilliant. So how did we average that? So that's 14 in one. We had 0 in the second. I'm going to take one from over this side. So I'm spreading them out to try and get this sort of a representative sample from this patch of sea ice. It's what we've been doing in the fjord as well. We've been going to different sites on the fjord, and we can go outside and have a little bit of a look at that in a bit. Oh, dropped a bit of my sample from the end there. Put this one in here. Oh, Being much more careful if we're doing this for real. Wow, we've got a very, very abundant sample here. Again, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 20 pieces of microplastic. So 14, someone making a note of this. 14 plus 20 plus 0. I'm going to do one more. And I've done one here, one here, one here. Let's go down in the middle here. And this is you know, what scientists are doing. They are making these cores through the ice and trying to see. This is not what scientists are doing, is wiping their hands on their trousers in between samples. Much more careful than that. There's some tiny bits there, I'm just taking note of those. Really, really important to make sure that you're not getting that contamination of samples. You're doing a better job than wiping your hands on your trousers to prevent that. A lot of rinsing's happening, both with seawater on the outside of our nets to wash the samples down into the end, and also using distilled water to rinse the samples with inside, so there's no contamination. That again is a dud. So 20 plus 14 plus 0 divided by 4. Who's going to be the first to do that little bit of maths? I think I've got the answer in my head. I'm going to sit down and try and warm up my hand, because handling Arctic snow, not always that comfortable. So we take an average, and the average of our samples, of course, brilliant maths students across the world who are going to be telling me 8.5. Fantastic for all of you who had 8.5. Look at that, 8 remained to 2, 8.5. Fantastic to those students in Miss Ferrer's, Woolston's and Woods classes. Really, really good. Tim says 8.5. Tim is spot on. Now, I've got an average of 8.5. I then need to work out what the volume of ice I got in each core and how many of those cores would fit into my entire Arctic Ocean. And I would say, based on that, about, if I said, 425 cores I could get out of here, that would mean, on average, what would that mean on average? Get 425 cores, on average 8.5. Someone do the maths here. And someone do the maths, 425 times 8.5. Who has a calculator to hand? Because my brain is frozen. What do you reckon, Ellie? Have you got a calculator over there?
About 3,500.
About 3,500. Fantastic. So that's the kind of way that we're doing sampling. I just want to take you outside to show you where we've been sampling before we come in and answer some of your questions. I'm just going to take the peppercorns off here. I mean, it's interesting because this morning we did this and we got an average of about 2.5. And so it is interesting, the more samples you can take, obviously the better it's going to be, because there might be variation of clusters of plastics. You might miss all those clusters, but the more you take, the more likely it is that you're going to find a good average that accounts for the entire area that you're looking at. And we've been following those general guidelines. I'm just going to take you outside to tell you a little bit about that. I'm going to grab the other microphone so we don't have that dangling here. I'm also in my socks. My big, nice, warm Arctic boots are by the front door. So if I don't stay out for very long, does that go over both mics? Is that okay? Nice furry mic cover, and it's going to be a bit breezy outside. And give you a bit of a view down here. How's that in terms of sheltering from the wind, Ellie? Fantastic. So if you can see behind me, you can see the Condensation, and those are the waters where we've been sampling for plastics. So we've been at some stations, and there's the sites that scientists visit over and over again. At the head of the fjord, where you can see the glacier there, so dodging around bergy bits, small icebergs in the water, and we've done 3 tows, 3 plankton trawls for 10 minutes each at each of those 3 sites here. We've also done some of the central fjord, and then the same thing out in the outer fjord. So we don't just come to one place in the fjord and think if we measure the concentration of microplastics there, that's representative of the whole thing. We make sure that we're sampling multiple sites, and not only that, but sampling multiple times. There's also the need to be very, very careful. I talked about rinsing, not contamination, not doing the sort of cross-contamination thing of wiping your hands and your pants and your trousers. That's definitely wouldn't be terribly professional. So a lot of care is taken to make sure that the samples we do take are an accurate representation of the waters here. I'm beginning to lose sensation in my toes, so we're just don't focus on my toes. So I think we'll better go back in. There we go. So cold toes, just to give you a sense of what it's like outside. And take off the wind muffler and then come and sit down. Great, and great to have these questions. We're going to start off with Mr. Where are we? Mr. Ladd's class at Northwest Village School, Plainville in Connecticut. Thank you so much for joining, and thank you so much for sending in your questions in advance. That top question, what are you studying? I mentioned ocean acidification before, and we're also talking about microplastics today. So we'll come on to microplastics a bit more, and hopefully that will be a big part of the discussion. Just remember, in about 2 hours, just under 2 hours, we've also got an interview with Nick Scott, who's part of the plastics research team. But it's really looking at human impact on the ocean. And ocean acidification is the process by which sort of increased levels of carbon dioxide in the atmosphere are absorbed into the ocean and through a chemical reaction turn into carbonic acid, and that increases the acidity, lowers the pH of the waters here, and that change in ocean chemistry can have a big impact, especially on those animals that have a calcium carbonate shell or structure. Now, calcium carbonate is just the name of a mineral. Chalk is calcium carbonate, and it's the mineral that shellfish, mussels, oysters, other marine creepy crawlies such as crabs, making their structures out of calcium carbonate. And if the chemistry changes, that can become much harder. So we're looking not only at how the ocean chemistry is changing, but also how that might affect some of the animals that live here. So those are the things we're studying. Great question. Second question from Plainville. How did you get involved in this research? Well, I don't come from a science background, but I've been very, very lucky to have worked with many research expeditions in the polar regions, amongst other places. And I've become more and more interested in the oceans, in the polar oceans, and how they're changing and how we're affecting them. And with the support of XL Kaplan, our sponsor, and universities and research institutes in the UK, that we put together a team from Plymouth Marine Laboratory and the University of Exeter, with support from NERC, a research council in the UK, and the British Antarctic Survey to do some research here. So it's really from an interest, a passion, and over the past few years have been able to bring together a team to achieve this research here. So it's been very, very exciting journey. Wow, so what have we got next? Here we go. What kinds of food do you guys eat? Well, on this trip, we're very, very lucky insofar as we're based at the UK Arctic Research Station, as I mentioned before. And there are several research stations here in the Ålesund, catering for different countries, and we all eat in a central dining hall. So the food is fantastic for the polar regions, and pretty good for anywhere, in fact. And so there's a selection of salads, and so we had pasta for lunch, and the cereal, and toast and porridge for breakfast, sometimes curry, sometimes fish and chips, that kind of thing in the evening. So it's really, really great food to have up here. And a big load of cake often in the evening, just in case you need that extra few calories to help with the cold. Again, Mr. Ladd's class, how can we help stop the pollution problems? Well, talking about especially microplastics, one of the things that we're seeing is that we use so much single-use plastic. Plastic has a lot of uses, everything from medical purposes for keeping things sterile and safe in hospitals, but all the way down to a bottle of water, which you might go and buy from a convenience store, drink in about 5 minutes, and then throw away. And it's just to realise that when you throw something away, when you use something once and throw it away, there isn't really an away. And that bottle that you put in a bin because you're all great students and you dispose of your rubbish properly, but that can go, if it gets mixed up, can go into a landfill site. Landfill sites near the coast that can blow off, that litter can blow off into the ocean, and then that can become brittle in the harsh sunlight and get broken down by wave action and end up after many years being microplastics somewhere like the Ålesund, somewhere like Svalbard. So in terms of stopping that pollution, it's really stopping it at source, and that's where you are. So if you use plastic shopping bags, single-use plastic shopping bags, try to use a tote bag or a reusable bag. If you're in the habit of buying water in bottles, try taking a refillable bottle with you. Teachers, if you get takeaway cups on your way to school of coffee, try thinking about using a reusable cup, and those are great, and you can cut down on those single-use items that we tend to throw away. What might be quite interesting for you guys to do is to do an audit, a checklist of all the plastic you use in a week, and then consider what options you have. Can you refuse plastic? Can you reduce the use of plastic? Can you then just recycle or reuse what you do have, and see how you can cut down on your use of plastic. Here we go. And what happens if animals eat the plastics? And that's a really, really great question. Plastics and its impact on the marine environment is an emerging part of science. So we really need to look at this on a species by species basis. Of course, some of you will have seen those shocking images in the media of turtles or large marine mammals like whales entangled or sort of speared by plastic debris in the oceans. Some very, very shocking photographs of seabirds who have their stomachs full of plastics. So what we have, first of all, is entanglement, and that's affecting some animals. More commonly, we find problems with eating. So a variety of size of animals eating plastics. There is some evidence to suggest that it can inflame the guts of animals, the stomachs of animals in the ocean. But by and large, if you're eating plastic, everything from the tiniest sort of bit of plankton, if you're eating plastic, then you're not eating the food that you need to grow and for all your other functions, such as moving around, hunting, getting food, those kinds of things. If you're eating plastic, it's a bit of a dud. And so you've got these animals confusing plastics for food. The tiny microplastics we're talking about in the Arctic, could be the same size as bits of algae. And so we have the plankton here potentially confusing those two. So it has a variety of different forms of harm on the marine environment. Where are we? Fantastic. We've got some great questions coming through on the live chat, and I'll just switch over to that. So, Mrs. Soskill, your class would like to know what kinds of animals live on Svalbard and how microplastics affect them. Well, we've just covered a little bit about how microplastics affect marine life. It's very much a marine ecosystem here, habitats. So the types of animals that you'll find out here, you've got the tiny animals at the bottom of the food chain, the copepods, the amphipods, pteropods, krill, the plankton. They're eaten by fish in the fjord. You then have seals that might eat those fish, and then polar bears that might eat those seals. Along the coast here, you can see that the snow is melting, and you'll get some reindeer grazing. You might see, if we're lucky, just out of here, an Arctic fox playing around, and then there are an increasing number of seabirds coming up here. The wonderful little auk, some great eider ducks, and also some different gulls and fulmars. And there's a songbird up here. There's some wonderful and delightful sounding snow bunting. So those are some of the animals that you have up here. In the summer, we'll probably see some walrus, whales coming through as well. Hello from India, and just going to hear from Livingston High School. How do microplastics specifically affect marine life? And are some more affected than others? It's a great question, and it's an area of current research. So finding out both in the wild and in laboratory studies how microplastics and what concentrations of microplastics are going to affect different marine animals. And so looking at that more and more, there are some theories about how microplastics can stick to small organisms. There are some scientists looking at whether these microplastic particles can carry other pollutants into the bodies of marine animals as well. But emerging science, we're just looking at how much plastics there are, how many plastics there are, and also whereabouts in the ocean they can be found. So a lot of work to do. So please do keep on studying science and come and help out on these very, very important questions. Question from a student here from Ms. Woolston's class. What is your main goal of researching this? What are you trying to stop? I think that's a very interesting sort of way of phrasing it. What we're interested in is how the environment is changing, how the Arctic environment is changing, and how human impact is affecting that, and finding sort of evidence. Now, with that evidence, we can then start to make better informed choices, both as individuals and as society as a whole. So, what are we trying to stop? We're not trying to stop anything, but I think when you see some of the evidence, then on a personal or community or national basis, you can then take better informed decisions. And certainly there is good evidence in the UK. We've had great work by the University of Exeter and their research supporting the government in the UK making laws about limiting single-use plastics, taking microbeads out of cosmetics, and putting a charge on single-use plastic bags in shops. So science can inform society and on what route we want to take. Here we are. Livingston High School. Your sample had a relatively high standard deviation of 10.1 into your relation to your sample size and mean. In the real world, what is the best way that you decrease variability? It's a really great question. One of the ways is, of course, if you're looking, the natural world doesn't behave in a uniform way. So we might find, and we do find actually, that microplastics tend to happen in clusters. So you are going to get that natural variability. But of course, the more samples you can take, the better idea you're going to have about that. What is a better looking mean for the whole area. So the more samples you can take, the better. But also to consider that there might be other factors affecting that variability. So, for instance, I haven't done it very well on my CI sample here, but we've talked about it in the fjord. So I know that, for instance, I've got some samples, and we know the GPS location for them are going to be at the back of the fjord. I've got some that are in the middle, and some are out towards the ocean. What other factors? We've got basic sort of physical oceanography as well, temperature, salinity, and how that changes over depth. So we can start to try and understand if there is variability, why is that? So not necessarily a case of decreasing it, but understanding it and having enough different samples. So you've got to feel that that's not just because of your sample size, but there might be other reasons for that. Great question. From Miss Wood's class, I said that the best way to reduce plastics in the oceans is to stop using them as much. However, is there a way to remove microplastics that are already in the Arctic? There are ways of reducing and removing microplastics that are in the Arctic. For instance, during our sampling, we have been removing microplastics, or we don't know yet because we haven't looked at the samples, but it is sort of, we could have removed microplastics from the Arctic Ocean. But it is incredibly energy intensive and resource intensive to do that. And so I think that we do have to look at, working on this problem of plastics at source, rather than spending a lot of energy and resource trying to get it out of the ocean where it already is. It's going to be interesting also to see whereabouts in the ocean it is as well, because until we know that, we can't even start to think about some of those technological solutions that may be appropriate, but at the moment haven't seemed to be that appropriate. So let's look at the problem at source rather than where it is out here in the Arctic. Great. From Ms. Carrera's class, educating people is very important, and that's what we're all doing. So thank you very much to all you educators and teachers out there. However, don't you think there should also be laws to rule this nonsense use of single-use plastics? And I think that comes to a very interesting point in the way that we talk about this in classes. And I've tried to sort of mention this or give a balance to this when we've been speaking about plastics and also ocean acidification and the issue of atmospheric carbon dioxide in previous sessions. And that's that, you can take action at various levels. You can take it at a local, national, international level. And taking action doesn't have to be individual behavioural change. And by that I mean, It doesn't all come down to an individual saying, I choose not to take that plastic bottle, that single-use plastic bottle. I choose to have a refillable plastic bottle. And that's great for that to happen. But there's also an opportunity for young people to do something called advocacy. And advocacy is where you want a change to happen, but it's not in your power to make that change. And the way that you can do that often with laws is by writing to your representatives and say to them, what are you doing to address the issue of plastics in the ocean? This is the evidence that we have. It's something we need to make laws against. It has been shown in other places the most effective way is this. And then you can start to get change. If that's a mayor of a small town doing that, if it's a state senate passing that, if it's a federal government or a national government doing that, those are all great, but it comes from often individuals and groups asking for those changes to happen. And then representatives, politicians know not only is it the right thing to do, but it's also a popular thing to do. And very often those two things have to come together. So putting pressure and asking for changes to happen is an important thing to do as well. Where are we next? So it'll be interesting to see if Ms. Correa's class, what you think about that. Mr. Soft Skills class, question from Doug. What vehicles do you use to travel to Svalbard, boat or plane, and to get around to do your research? A great question. We fly up here, and so for me, based in London, that's a flight from London to Oslo, the capital of Norway, and then from Oslo to Longyearbyen. And Longyearbyen is the main town of 2,500 people, but has commercial flights. And then we get a short hop in a smaller plane over the mountains from Longyearbyen to Ny-Ålesund, the research community where we are now. In terms of getting around, if you're doing research on the glaciers, you're probably looking at, about going up by Skidoo or snowmobile. And if you are going out to research on the fjord, then a boat is probably the best option for you. Otherwise, you probably get a bit cold and wet, and it's very cold out there at the moment. The sea temperature is something between about plus 0.5 and minus 0.5 degrees Celsius. So that's looking a bit like between sort of 33 and 31 Fahrenheit. Great. From Vida and Akshita, is there a way to get rid of microplastics that are already in the water? This is something we covered a bit earlier in the chat, and really going through the fact that the current methods that we do have available to us to take microplastics from, example, the surface waters, are so resource intensive that it's almost counterproductive to do that. So best to tackle the problem at source rather than here in the Arctic, looking at where the plastics might end up. Okay, we've got from Ms. Wood's class, robotics team members. Fantastic. Do join in the robotics work that Digital Explorer are doing as well. But great to have you on the ocean side. Can robotic components be put into water treatment plants to prevent microplastics from polluting our drinking water? And Dakota, how does a video camera work in that climate? That's a great question. We'll come on to filming in the cold in a bit. I don't know enough. I mean, we're talking a little bit about some of the tools that scientists use to detect different types of plastics in the lab. And it takes a long time, and they're quite large pieces of equipment. So currently, we don't have commercially available that kind of technology, but it doesn't mean it's not possible. And it's exactly the project a robotics team should be working on. It's quite complex. Maybe we need to put you in touch with a few people but it's exactly the kind of innovation that we need to help out with this problem. I mean, one of the simplest things is to start putting filters or better filtering systems on wastewater. So that might be, was an eco egg, Ellie?
Yeah.
An eco egg is a egg-sized thing.
Like a net bag.
A net bag, okay, brilliant. And you can put that in your washing machine, and that will start to collect all the plastic, sort of microfibers that come off sort of synthetic clothing when you wash it, and collect that in your washing machine rather than that going out into wastewater. So there's other technologies we can use as well. How does the video camera work in that climate? I think there's three things to think about with video cameras at minus 40 or whatever. At the moment, it's super warm in terms of filming. First of all, is that electronics actually quite like the cold. It's batteries that don't like the cold. So quite often you'll keep the batteries in a pocket and keep them nice and toasty until you need them, and then sort of swap them around to warm up. So electronics like the cold. My fingers don't like the cold, so I've got to be very careful touching metal often on these cameras. And my fingers aren't what they used to be after holding a camera for long times in the polar regions. But the last thing is moisture, which is a really big problem. And it's a massive problem also with breathing. So if you're taking a photograph or using a film camera and you're breathing out, suddenly you've got this huge great cloud of steam around your camera. So very often what you'll have to do is you'll be wanting to film something over here and hold your breath and do your filming and make sure there's no steam going around it, because the steam can then condense on the camera. And that's okay-ish when it's ice. It might condense on the lens. You've got a bit of a blurry sort of look to it. But what the big problem is especially taking your camera into a tent, it gets all fogged up, and then you go back out into the cold, and that's frozen on the electronics, and you've got ice all over the electronics inside your camera, and that's definitely when things start to go wrong. So there's some tips on cold weather filming and photography. I could go on, but we'll come back to the live chat. Lots of problems I've faced and lots of things have gone wrong. If the water, this is from Ms. Kleinhentz's class, if the water is so cold, how does it not completely freeze? Really good question. So that seawater, so the salt content, means that the freezing temperature of seawater is between about minus 1.6 and minus 1.8 degrees Celsius. And when it comes to points of Celsius, I can't do my Fahrenheit conversions very well, but that's sort of down to probably sort of 29, 30 Fahrenheit. So seawater doesn't freeze at the same temperature as fresh water, and that's because of the salt content. And you probably could work this out if you live somewhere where there's snow and ice in the winter, and that's because we use grit, which is a high salt content, to melt the ice. Here we go from Ms. Ferrer's class. Can microplastics from the Arctic travel to other locations, like by the movement of glaciers, etc.? So it's a really good question, and what we'll know, or start to be able to tell from the research that they were doing, into the Arctic Ocean here, are the microplastics coming from plastics that we're finding which are sort of airborne but settling on the glaciers here and then coming down with the melt? So are we going to find more by the glaciers? Are we going to find more microplastics coming in on the ocean currents from the Atlantic? So until we know where they're coming from, we can't answer that question too much. But what other researchers are finding is that in fact that the microplastics are coming into the Arctic Ocean, and once you come into the Arctic Ocean, there's not really anywhere else to go. And they're talking about the Arctic potentially being what's called a sink, or where plastic particles are collecting in the oceans. So it's just a few papers scientific papers, pieces of science research that have been done on this. So much more to find out. So Miss Gilchrist class again. Christian and Aishu have been researching microplastics with the robotics team. They would like to use you as an expert for their program. Could you email your first and last name? Certainly do be in touch with the Digital Explorer team. And I might not be the best person, than probably far better experts out there, but we'll be sure to connect you with the right people. Now, it's great that you'll be working on that. That's really, really great. Miss O'Malley's class, this is a question from Drew and Addison. Is there ever a way for microplastics to completely dissolve or be broken down through animal movement or weathering? That's a really good question. So often it is weathering in the first place that is creating the microplastic. So it's that brittle plastic bottle breaking down over time with the motion of the waves and the motion of the ocean currents. And smaller and smaller and smaller and smaller particles. Now we've been talking about microplastics, and you have to have a really, really fine mesh. Those are fractions of millimeters, a fine mesh net to find those. Those even smaller particles, with breaking down even smaller and smaller and smaller than that, it's something that we haven't been able to sample, so we really don't know. It would really be looking like a sort of, as Nick said in the session earlier, like looking for a needle in a haystack, or in fact a needle in a very, very, very big ocean. From Aidan in Mr. Soskill's class, your work sounds dangerous with the conditions there. Have you ever been injured doing research there? Well, luckily I've got a big bit of wood here to touch wood, and luckily I haven't been injured, but there have been injuries in the Arctic and on teams I've worked with. And so, yes, you're right. You have to be very, very careful, safety first. And especially, you can't take unnecessary risks because we're in a very, very isolated environment. If the weather came in, there's a doctor on the end of a phone, but getting medical help to you, it's at best a doctor on a half-hour helicopter flight. I mean, if you need to get to hospital, getting that helicopter back to Longyearbyen and then on a jet to the mainland of Norway to get to hospital. So yes, respecting the Arctic environment very much. There are a lot of people here who've received medical training, but in terms of a fully qualified doctor, not with us in the Ålesund. From Lauren S., student question, what is the warmest it will get where you are? What does summer look like here? It's a great question. So warm for here is about 50 Fahrenheit, 10 Celsius. And what you'll find, these strips along the coast, all the snow will melt. You'll start to get some grasses. I think there's a tiny wee tree, the Arctic birch, a tiny wee, sort of an inch high, a couple of inches high, and some wonderful flowers like saxifrage. And you'll see sort of more bird life coming in, geese and ducks migrating up from the south, probably some more reindeer grazing. And so it has a summery feel, probably a bit sort of alpine, the Alps in Europe, that kind of snow-capped mountains, but some vegetation lower down. I've never actually been here in the summer. I've really, really seen white. So maybe one year I'll come up in the summer. From Miss Wood's class, from Hank, what are your expenses? How much money do you have to raise in order to complete this expedition? Really, really great question. So this expedition is supported by XL Catlin, who've been a great supporter of oceans expeditions and oceans education over the years. It's also done in partnership with scientists from Plymouth Marine Laboratory and the University of Exeter. So they're providing the support and their time to make this research happen. And then we are very, very brilliant support from Nick Cox, the station manager, a member of the British Antarctic Survey team, and the British government provides the funding for the UK Arctic Research Station here through the Natural Environment Research Council. There's a big collaborative effort. I think one of the easy ways to sort of break down how much science costs is to look at how much it costs to have a paper on average. So a scientific paper is where your results get published, and on average to have a decent paper it sort of costs about £100,000, $150,000 or $40,000. I'm not sure what the exchange rate is at the moment, but that can vary wildly. So you might have quite a small piece of research that costs less, or a huge piece of research out on research vessels crossing the Arctic. So there's lots of different factors there, but it's been wonderful support from all those organisations, companies and individuals involved in the Arctic Live Research Expedition. Crikey, but we're way over time, aren't we? Ellie's been very kindly pointing to her watch. I just thought she had an itchy wrist. But we're over time for this session. I think I'm looking down. We've got too many to sort of fit into the last moment. We have 2 more sessions today. So in an hour's time, we have an interview with Nick Scott, a member of the plastics research team from the University of Exeter, and then an Ask Me Anything open Q&A in about 3 hours' time. So we will come to those questions in future sessions. But for now, I'm very sorry for this quite abrupt end. I hadn't realised how far over time we were. Thank you so much for all your brilliant questions. I sort of got carried away. Really, really great questions from the students. Be very, very proud of yourselves because it's been fascinating hearing sort of almost how you're thinking through these issues affecting the Arctic and part of your lives too. So until the next sessions, it's a very big thank you and goodbye from the Arctic, and look forward to seeing you online very soon. Bye bye.